Hey everyone, in this three-part video series, we are going to take a deep dive into RAG or Retrieval Augmented Generation. In first video, we will try to understand what RAG is. In second video, we will work on a project and I will give you a line-by-line walkthrough of the code so that you are able to understand what each and every line of code is doing. And in the last video, which will be the third video, we will move that project from research phase or from Jupyter Notebook to productionization phase. After watching all these three videos, you will have a very good understanding of a RAG system and its application. So in this video, we will take a look at what RAG is and why it's so crucial for building more accurate and reliable LLM applications. We'll also explore the architecture of RAG, showing you how all the different components fit together. You will also learn the magic behind how a vector store is created, the very heart of RAG's retrieval capabilities. And finally, we will see how the retriever works to fetch the most relevant information to augment our LLM's response. So let's jump right into it. First, we will try to understand it using an analogy. So here, think of a scenario where there is an open book examination going on, and this is the student who reads the question from the question paper, and now he or she will try to find a relevant chapter from this book which is relevant to this question, of course. And once they find the relevant chapter or information, they try to use that information to generate the proper response or the answer, and then they write it in their answer sheet. So basically that is what RAG is. It is a combination of two models. One is a retrieval model and the next one is a generation model. Now let's take a look at the architecture diagram. First, let's talk about this part, because this needs to be created, or the vector store needs to be created before the user asks for a question. So here you have, for example, certain set of documents. These can be research paper or any other type of document. You need to process it and then you need to store it in the vector store in a form of a vector. So you'll have to do certain things like chunking, embedding, and indexing. And once all of those things are done, you will store it in the vector store. We will talk about these parts a little bit further in this video. So after doing this whole text processing side of things, you store it in the vector store, and now it is ready to be used by the retriever to retrieve the relevant chunks. Now, when the user asks question, retriever goes and looks into the vector store and retrieves the relevant chunks. And once it has those relevant chunks, it combines the chunks with the question which the user asked before, and then it sends all of those information to large language model. And this is where the generation part happens. And once the response is generated, it is sent back to the user in the form of answer. And it also includes the source document or source chunk which have been stored in the vector store. So all in all, this is how the RAG works, and there are a lot of interesting things going on under the hood, like how the vector store is being created using these steps, and then also how semantic search works. So we are going to talk about that next. Let's first understand how the vector store is created. So imagine you have a document, and this document contains, let's say, 30-40 pages. You are not going to store everything in just one go. You will first have to chunk them, and then only you will be able to store them. So here I have chunked them in a very discrete form where there is no overlapping. But the problem with that is sometimes the context may be lost when you break them like this. So usually what should happen is there should be some overlap. So let's say this is the first chunk. This is going to be the second chunk. And you can see here there is certain overlap. And then you will create third chunk. And then again there is some overlap. So this is how the chunks are going to be created, with some sort of overlap between subsequent chunks. So once the chunking is done, we will have to do the embedding. So think of embedding as a step where you convert from one language to another language. For example, you are someone who understands only Hindi, and if the document is in English, you first need to convert that into Hindi to be able to understand that. And for that, you will use a Hindi dictionary. So just like that, here we know that computers don't understand plain English, so they only understand mathematical representation of those words. So we will use OpenAI's embedding model. If you're trying to use some other large language model, you can use their embedding. In this case, we are using OpenAI's embedding model, and that's what is going to act as a dictionary. So all of these numbers or all of these documents are going to be converted into numerical form, and they will be stored as a vector in the vector store. But these vectors are not going to be stored in this way. They are going to be stored in a form of various clusters, and each cluster will have similar type of vectors. And for this, any clustering technique can be used, for example k-mean or hierarchical clustering. This helps the vector store to create index, and when you ask a question, it need not scan the whole vector store or whole database to search for the similar clusters or similar type of documents, and it can just use those index and directly go into a specific cluster and pick the relevant documents from that cluster. It just speeds up the process of fetching the relevant chunks and documents. If you don't know how k-mean or any other clustering algorithms work, do let me know in the comments. I can create a separate video on that. Now let's try to understand how retrieval step works. So for retrieval step, there are a lot of different type of similarity search algorithms. One such algorithm is cosine similarity. So the way cosine similarity works is by looking at the direction of two vectors. If they are in similar direction, that means they have similar meaning. If they are in opposite direction, that means their meanings are completely opposite. And if they are at 90 degree or if they are perpendicular, they don't relate in any ways. So let's say this is the query vector, and we have three chunk vectors. This is chunk vector 1, this is chunk vector 2, and this is chunk vector 3. And let's say this angle is theta, this is 90 degree, and this is 180 degree. And we know that cos 0 is 1, cos 90 is 0, and cos 180 is -1. So if the cos theta of two vectors are close to 1, that means they are similar. And if the cos theta is close to -1, that means they are completely opposite to each other. And if the cos theta is 0, that means they are unrelated. So based on these values, retriever can decide which chunks to pick and which chunks to exclude. So this is how the retriever step works. Once the retrieval is done, all those things are sent to the large language model, and large language model just tries to understand all the information along with the question, and then it formulates the response and send it back to the user. So that's how the RAG system works. So I hope you were able to gain high level understanding of how RAG works, and also some of the detailed stuff like how the retriever works and how the vector store is actually created and why it is optimized to search for the key chunks and how it actually works. And as mentioned before, in the next video, we will try to create a project which will use all the things we learned in this video, where we will try to create a vector store based on a research paper, and then we will try to ask questions very specific to that paper and see how the response is before and after the vector store is created. And the video after that, we will try to create a productionizable version of that project, and we will create a UI so that it can be used and consumed by the end user. So I'll see you in the next one. Happy learning.